Hello. Again, it's give me a couple minutes to finish setting everything up. It's gonna take a minute. For everyone that's here, welcome. Sorry about that. Just took a couple minutes to get everything up and running. And gonna let this finish. This is Focus Friends. I've made a couple videos on that. If you have any questions, just throw it in the comments on chat. Okay, so today we are working on a project that I believe I started on the last live stream I did, but I've worked on a couple other videos since then, so I can't be sure which I started in those videos and which I started in the live stream. Again, if I prepared myself, this would have been fine. So the project is a Arduino Nano with a LCD display without a... Oh, that timed out. Yeah, I forgot I had that set as a 5-second timeout. And so that means that we should be up and running. So this is the module I put together, and I will explain it in just a moment while I pull this up. Yeah, let me make the camera full screen, or fullish screen. And go ahead, move the logo to the corner, give me a little bit more room. That should be fine. So this is the module, and we're going to finish up our focus friends round. Maybe start another one. Yeah, made 5 socks. Okay, that tablet is not operating fully, so this, I didn't get that centered. So what we have here, and I guess I don't need my headphones on because I already checked the audio level for the live stream. So we have an Arduino Nano, or a clone, which is from Micro Center. It's an inland with a UART controller, and I'll just drop things on the floor. So it appears to be pin compatible with an Arduino, and then previously, let me see if I can find my other stuff. So previously I had worked on this module, and I don't know how, again, I don't know how far I got. And this one has the temperature probe on a extended wire, and those are the only ones I can find at the moment. So just to show you what this one does, I still need to work on the Wi-Fi, and again, I can't remember which videos I did on this so far. So I'll grab that, grab a battery, and did this lock up? Yes. I don't know why that is. Hold on, let me try to reset the video. Give me a second. I think the easiest way to do that is to unplug it. And plug it back in. Come back. Okay, did it come back? Yes, I think it did come back. Yes, it came back, and so I may crash it again. I thought I had fixed this issue. So for some reason with this camera, if my hand, I don't know if it like overloads, but if, let's see if this happened. If I move my hand too close to the camera, it's not doing. It's something with some type of motion with this camera. And I had changed the settings on this to try to get the contrast to work, because I think this is still, and I'm getting a glare probably from this screen. Take that off. Yeah, so the still can't get the contrast just right, and so this is basically how the screen should work. But let me go back and before I troubleshoot this, let's troubleshoot the camera. So video capture. Nope, it's still 1020. Wonder. Yeah, it's still full color range. Let me see if I lower. Yeah, the bright, all the settings there. Yeah, not really sure why that locked up. But again, maybe it's because I made it full screen. I made it full screen and I moved the logo. Those were the things I did. But that shouldn't change the camera locking up. I did make a video a while back on, well, let's go take a look at that real quick. On, let's see, it's somewhere on my YouTube channel. On a Mac, on how to, and I don't have the browser set up. And there's the live stream that we're watching, and it looks like 2 people are watching that. Outstanding. When I'm looking in YouTube Studio, it may be up to 6 people watching. Okay, thank you. So these are the last couple of videos I did. There's the one on Focus Friends, and this was for my Mac. Okay, so I made a short out of it. So yeah, this video here, which I'm just gonna click on it because I need to get to the description. And I don't mean to play an ad on my own video. Wait, I'm not even monetized, so that doesn't even matter. If you want to help me get monetized, go ahead and subscribe, and more importantly, watch more videos. I think that would help more. So yeah, this is if resetting a USB video capture. And did I not include? Yeah, I need to reset VDC Assistant. So I need to remember the proper serve. Okay. So on a Mac, it's a VDC Assistant. So let's search VDC Assistant. Yeah, I'm not gonna spell anything right. To Linux. VDC Assistant on OBS. And again, this is running on my Mac, so let's see what we can do. So is the video, yep, video capture still working. I haven't crapped that out yet. And let's go ahead and go with ChatGPT. Let me just get ChatGPT to load, and we will see if we can get ChatGPT to answer this question. And then I'll make a video on that and link it to the video we were just watching, which okay, so let's go ahead and see. And let's see how we should phrase this prompt. Let's see. And if anyone wants anything, throw it in the chat. Or have any suggestions. On a Mac, there is a call it a service called VDC Assistant. What is the equivalent service? And I just spelled service wrong on Linux. I think I just spelled Linux wrong too. I can't type. And something just went wacky with the chat. I don't know what. Let's see. Okay, that cleared it up. Enter. And that should work. Okay. This is going to take a little while. I don't know why this is taking so long. Okay, we're going to give this, well, that we run that, we'll wait for the prompt to come back. Go back and activate the camera. And we'll do a 5-minute timer on, and of course, putting this down right on top of my projects is probably screwing things up even more. But we'll let that run for 5 minutes while I try to figure this out. Probably should change the brightness, but at least with looking at that, I can tell if the screen has locked up. And automatic is the background service for camera access. Yes, blah blah blah. Unless there isn't a single direct. Okay. U video. The node, yeah. Pipewire, UVC video. Let's take a look at that. Let's see. Whoa, that's not what I wanted. So this should be my terminal, not OBS. I need to find a better way to do this. Okay, so terminal. Okay, let's go ahead and just move that right there. Yeah, sure, that's a good spot for it. So what was it? PS AUX UV pipe grep UVC. Okay, these are all K worker. Okay. Okay, so let's see. Okay, we'll go ahead and try something different. We'll go ahead and find that. Okay, so I can try. Okay, so I should try this in the future. Okay. Let's just try this prompt. Go ahead and have a drink of water. And this prompt is taking too long. So let's go back to our little timer here for Focus Friends. Have a drink of water. And then once this timer's up, we'll actually set up a Focus Friends equivalent, or a session, or focus, or whatever. Yes. I can't focus. Even if it isn't a mobile device that's distracting me, I can't focus on most things. Anyone else here have difficulty focusing? If you do, let me know what helps you focus. Okay, so it looks like I have about a 10-second delay here. So on my viewing this on YouTube right now, I have 25 seconds on 25 seconds on YouTube Studio and 10 seconds on OBS. So OBS is doing it live, and YouTube Studio is about 10 seconds off, and then actually viewing it on YouTube is another 5 seconds. So about 15 seconds it looks like. So let's see. How long are we going to do this live stream? Let's yeah. Either way, let's go with 2 hours. Now, while we were playing around with that, let's see. Did the prompt give us anything? If you want to, you did. Yeah, so want to kill the process, kill. Yes, I know how kill works. Okay. Okay, so LSOF. Let's see what LSOF. So man, LSOF. List open files. Okay, I'll play that game. LSOF/dev/webcam main. Okay, so it's dev video. Okay, so OBS, it's showing that OBS is opening it twice? Maybe. Dev video 2. Okay, same thing. OBS. What other devices can we look? I can't remember how. Hydra 0? Let's go with Hydra 0. Hydra 0. Nope. Hydra 1. What? Let's see. Media 0. Media 1. That's not showing everything from dev. Yes. Okay, so I stopped there. That's why. Okay. Got TTYs. Let's see who's accessing SD0. No. SDA, sorry, not SD0. Okay. SD1A. Everybody. And video 1, video 2. I still haven't figured out, so webcam is on video 2. So video 0 right now is, what is video 0? Video 0 is the webcam on the laptop, which is facing me, and you don't want to see me, and it's not even a good. Video 1 is something to do with the metadata, and I can't remember what it is. Like everything else, we're gonna play with ChatGPT. Let's see what ChatGPT says. On Linux, what is the difference between /dev video 0 and /dev video 1? And this is going to take a while. It's still not finished. Okay. Maybe it's finished typing. Okay. Hit enter. And while that's going... Ooh, did it give me an answer already? No, it just went... That's going to take a little bit. Let's go back to... Okay, Focus Friends is stopped, so I'll put that as, or screen locked up. Focus Friend is still running. And while that's running, so on this board, okay, I'm going to disconnect the power for now. I need to find a way to just put something that has a constant power, because these batteries, if they don't have enough current, will just shut off. And I do have this USB 4-port hub that I have the camera connected to, but I want to try to limit what I put in there. So I'm going to put this aside. I'm going to take this, actually, let me just plug this in right now. Just give me a second. See if this Hello World boots up. And nothing else. Temperature, it is 75 degrees Fahrenheit, 24 degrees Celsius in my office. At least next to some resistors. Oh wait, that wasn't even plugged in. I'll get to those resistors. So I did exactly what I said I didn't want to do, which was plug it into that. But actually, so I did find more of these. I could not find more of the smaller ones. Now that board uses USB micro. This uses USB mini, and I had tried powering it up with one of these, and I was able to power it, but no data. So this is gonna go somewhere. I'll hang this up on my light pole with my whatchamacallit light that does not light up anymore. My ring light, which I got on Amazon Prime, and then as soon as that died or stopped. Okay, and ChatGPT came up with an answer. Let's see what ChatGPT says. On a Linux camera to virtual device, video N node, where N is the number assigned in order. The key difference between video 1 and video 2 is usually the first video device on the system. On most laptops built in. Okay. Video 1 is the second device. No. That is not what I meant. No. Yeah, no, this... So there is a difference there, and I just don't know what it is. It's something to do with metadata. Oops, nope, I don't want the terminal. I want the camera. So this one uses micro. I did find one of the micro cables, and then I think this was on my last live stream. I was using this thicker solder, which I was having trouble with soldering these joints on this board. So I went ahead and I ordered a thinner solder. And then when I was cleaning up my desk for this live stream, I found the thin solder I was using. This one is 6040.32. Can you read that? Yeah, that's easy to read. This one is in 0.01, 0.8 millimeters. Okay. Yeah, we won't deal with ChatGPT on this. This is an easy one. 0.8 mm to inches. 0.03 and 0.03. Yeah, so these two are the same. They don't. Okay. So I haven't used this one yet. This definitely looks a little bit thicker. So this is 6040, and this one is probably yeah, 6040 or 6337. So neither of these are lead, and this actually says light duty, whereas this one, does this one have a, no, it just says the diameter. So this is 2 ounces, this is 2.5 ounces, this is 42 grams, which is a little less than 2 ounces. 2 ounces would be about 50 grams, so a little less than 2 ounces, unless the 0.55 is the equivalent. Okay, no, net weight. So the net weight is 70 grams, 56 grams. So yeah, this is a little less, and the spool is way too big for that, but I digress. We may or may not. And of course, I didn't have the camera on. Outstanding. Okay, so just to recap, this is 0.8 millimeters, 42 grams, 63% tin, 73% lead, so it's not lead free. The one I was using was, again, 6040, so not lead free, and 2 ounces, 56 grams, so a little more. And this one is actually the one that I was trying to use last time. Again, is 6040, It's 0.32 inches and it is 70 grams. And I've probably used quite a bit. And the other thing, the one I just bought, the spool, it's that pessimist optimist. Is the glass half empty? Is it half full? Or just this spool just too big? Which, if they have standard size spools and it doesn't matter to them, there's no sense in using different spools. So the manufacturing of the spool. I do have a battery for one of my cordless phones. That was when I was cleaning up. So let me clean up some of this other stuff. I was testing some stuff with some LEDs. So I just have a couple of these LED these breadboards. I just have random things plugged into them just to, if I need a component. So this will just go over there. And let's go over, what is happening on the, okay, let me try to get a little better light. See if, that might make things too bright. Okay. I really should have taken pictures so then I could. Okay, so what I was trying to do is use one of these smaller breadboards, and I'm like, oh, it will fit. No, it won't. And the reason it won't fit is because I screwed up. But so on the Arduino, on the V in, which I'm getting 5 volts out when I use it here, I'm using as the VCC, or on this LED. Let me grab my loop, and they call it VDD. I don't know what the difference between VDD and VCC is. So, and a little bit of a glare. Okay, so I have ground going to ground. I have V in going to VDD. Right now I have VD0, which is the contrast control for the screen, going to a voltage divider instead of a potentiometer, and that might be causing part of the issue. And we will get to that in a moment. So I don't know if my issue is wiring code, which I'll load the Arduino IDE in a moment and show you the versions of code that I went through. So that's the VO0. And then next we have the control signals. So the control signals are VS1, register select, RS, read write, RW, and E, enable. And those are being wired through this orange, yellow, and blue, which are all going to the Arduino on pins D11, D12, D11, D10. And then I have D1 through D0 to D1 going to, I believe, going from D9 to D2. I had originally tried to do D0 and D1 or pin 1, but those are used for the UART, and to program or to get any printing back, you can't use those. So in theory, and I kind of tested this, but is I could disconnect the items from these pins, program the UART, program via the UART the Arduino, reconnect those pins, and then use an external power source, and it will run because it doesn't need the serial interface. But it was just easier just to rewrite the pins. And then over here I have A and K, which is the backlight going through a resistor. So there's that. Now if I plug it in, magically it will work, but let's go ahead and plug this into the computer via this port, and let's see. Okay, still too bright. But I don't know if the contrast is working, so I have no idea if anything is. That's just a really bright pin. Yeah, I'm not seeing anything on the screen, so gonna leave. I really don't know if I've burnt anything out by my jimmy rigging, and I'm moving things around. I definitely. So let's go ahead and go to the code. Open the Arduino IDE. And it's still loading. Yeah, so I don't know if I have the contrast too high, too low, not high enough. I need to go check on something in a moment. Oh, let me. Okay, let's see. Let's see Arduino. Let's. Is there a rename? Yes, rename. Call this Arduino IDE. So I know which one I'm looking at. Okay, let's get this on the screen. Okay, so let me go over what I have. So I have this pin array, which I'm just setting to, I think that's hex 55, just to initialize it. Pin 10 is the enable. The read write is pin 11. Why do I have a feeling I have that reversed? Oh no. Okay, yes. Yeah, I'll double check that in a moment. Actually, let me double check something else. Give me a minute. Sorry about that. Okay, so back to the Arduino. So now D0 to D7 are pins 2 through 9. The setup, I'm using the serial interface because I cleared those lines, so I might as well use the serial interface for troubleshooting. There is a debugger, but it's not going to tell me if I'm sending something to the wrong pin. And so the debugger isn't going to tell me if I'm sending something incorrectly, but I'm using these statements to see where in the code it's executing, and then I will try to correct that. And so I'm setting all the pins to output. I don't need any of them as inputs. In theory, I can put it to an input and that would be fine. I could also hardwire the read-write pin to be an output, which, or be, I believe to write it would need to be low. I'll get to that in a moment. And I am using the 8-pin mode. I've tried using the 4-pin mode. I've tried using the 8-pin mode. I've gotten inconsistent information. So, looking through the data sheets, I've set up this pulse E, which I think I need to may have to break that down to pulse E command and pulse E character, and just change where the register select is. On here, I'm just, before I'm running the PLC, I'm running the register select. Reviewing some of the timing diagrams, I don't think that's gonna, that may be a possibility that I'm setting the register select pin at the wrong time and it needs to be high then low. I think more importantly is when the enable pin. So these, going through different items, and I think one of them, I think this last setup, as I went with the version that Ben Eater did for his LCD screen. He did the 4-pin, and I think I was forcing this to go with a 4-pin also. But let me see if I can find that video for you and throw it into the chat. Let's see, LCD. And I probably should have saved the other videos. So yeah, this was part of his connecting it to his 6502. His 6502 breadboard computer. So I'm running, so I'm running this command 4 times, and I'll look up. Yeah, so it's 1, 2, 3. Okay, maybe only 3 times. Okay, then it's a 4th time. So this should, I think with mine, should be 2 row, 8 digital bits, and I believe the 5x10. I don't have any specific data sheets on that module. So this is the 4th time I'm running it. Then I forgot to write what these items are, but it's always, register select is always low. And it keeps going. And then I set register select high. I forget what letter this is. Looks like it is hex 8. Maybe hex. Yeah. I really need to. Okay, then clear screen. I'm not running that now. I'm not running. I'm still doing a delay. And then I start print. Okay, so print 0, 1, which should be A. And then delay 900 milliseconds. I believe delay is milliseconds. And then go into the loop. And the loop, I'm also using the display char function. Okay, yeah, so I'm displaying A here with the char display. And I'm just printing out how many times I go through the loop so I can keep track of where this is happening. The setup data is, I believe I am setting this up correctly. So the most significant bit should be pin 0, and least significant bit should be pin 1. So I'm taking data, I'm ANDing it with there, that one is giving me the least most significant bit, and then the next, and each one I am bit shifting it there, and then I'm printing it out just so I can see if I got the data correct, and returning true. So, interesting thing that I found out, and I went to go make a video and I did not have OBS set up correctly, is and part of that was that OBS will not let me show the terminal screen unless I do display, and that just threw off the whole offset of the screen, and the video didn't work out. Fun fact, I did the video twice and neither time it worked out. So yeah, so needless to say, if you do not put a return statement, and this is not a void, what will happen is it will crash and restart, but it will compile fine. So then I'm writing the pins and just mapping the pins to digitally write. I don't think I need to put a delay here between each pin, because the pins are being I think the enable only works on a transition, so I don't think I need to set. I don't know if I need to set the enable pin before I set the data. I think I should be fine. Yeah, I should be fine. I'm printing the data pins again to make sure that nothing has changed. There's a way to read the registers, so I can actually, and I don't know where in the Arduino, so you can actually, it's like a digital read, but you're just reading the register that has these pins, and then it's a function I saw and read about, and before I really got into the Arduino. Again, make sure it's true. Now here's with the Pulse-E. So I'm setting the read-write low, because the read-write needs to always be low. So I'm making sure I'm setting the enable low, delaying, running setup data. So when I'm running setup data, the pin is already low, so I should be fine. I'm writing the pins to data pins. I am putting the enable pin high, waiting 2 microseconds, or I can't remember if microcenter is, let's see, help, reference, and I don't think this is going to pop up on your screen. No, of course not. Why would that pop up on your screen? Let's see. Of course, it loaded into Firefox for some reason, which I don't have mapped at this moment. Okay, so this is the reference page, and so pin mode is either read or write, I believe. It's a Boolean expression. So yeah, the pin is the pin number and the mode, and I don't like that doesn't give you and returns nothing. Okay, example, output high notes. The analog pins can be used as digital pins, referenced as A0 and A1, etc. The exception are the Arduino Nano and Arduino Mini and Mini A6 and A6, which can only be used as analog input. So I'm not using any of those pins because I think I read this already. So that's pin mode. Now, what I want is bit read. This is what I wanted. Bit read reads a bit of a variable specific. Okay, so in right here I can use the bit read, which I instead of let me close Firefox because I don't even have that mapped right now. So instead of doing this manual, go back there, this manual bit shifting. So this is the equivalent of the read, but I want to try to make this as part of the reason, and the reason I'm not using the LCD library is that I want to make sure that I'm using as close to the raw data. I don't know. Yeah, so it returns what the bit value is. So that's, and just so you know, I did use the LCD display library in testing this, and I got the same issue. So bit clear, bit write, bit set. So you can set a specific bit. What's the difference between bit set and bit write? This is making me interesting. Write to a bit in a variable. Int long blah blah blah, and floats on. Okay, floats in. Yeah, because right into a float, so it's bit right. X is the numeric variable whose bit we're modifying. Okay. N is the bit of the number to write, and write is 1 or 0. Okay. Now, okay. Okay, so bit set always sets it to 1, where I guess bit clear would, yeah. So if you do bit write with a 1, that's the equivalent bit set. If you do bit write with a 0, it's equivalent bit 0. High byte, does this tell you what the high byte is? Corrects the high most significant 8. Okay. Yeah, that's if you're using a 2 byte of. Yeah, so if you have a 2 byte word and you want to take the high byte and the low byte. Not doing anything with analog. Not doing anything with trig. Not doing anything with interrupts. Advanced I/O, no tone, no pulse line. Is this reads a pulse on pin, for example? Okay, so this is, for example, on the LCD. It's essentially doing this. It's checking for the pulse before doing anything. So that's kind of, you would need to set up an interrupt. Pulse in. Okay, so is there a pulse out? Digital pin to interrupt. Attach interrupt. Yeah, I'll play around with it. So is char is alpha numeric, is ASCII, okay, is digit, is graph, is hexadecimal, okay. Again, back to interrupt. So delay. So delay. Okay, so delay goes into milliseconds, which is what I originally wanted to go here and check anyway. And of course, I got distracted. So, and then delay microseconds. The largest value will produce an accurate delay is, so 6, roughly, okay. So looking at that, that looks like that is a 16-bit value. So you should use delay, which, did they say how long delay would go for? Allow data types unsigned long, so I don't know the I can do size up and try to get that. Okay. And then you have micro S. Returns the number of microseconds since Arduino board began running the current program. This number will overflow and go back to 0 after approximately 70 minutes. Okay. I just want to figure out, let's see. Was it return? Function returns a number of microcenter as a unsigned long. So let's see. $60 times 70, so approximately. Oh. Microsecond should be then 1,000? So 40 for 4 million. Let's see. And hex. Let's see if it'll convert that. Hex calculator. Let's see, will this let me do 4 times 4? Let's see. No, it needs to be a value. So what's it? 420000. I think that was the value. Hexadecimal is 3 bytes. So it's a 24-bit number. Okay. That's fine. Milliseconds. Let's see how long this will run for. About. Okay, so this is 1,000. Okay, I got my math wrong. Yeah, so about 50 days. Okay, I wonder if you can set a real-time clock with this. Random number, communication, SPI, print. Yes, this is serial print, okay. So the liquid crystal is the, oops. So it doesn't have I2C, but has wire, which I believe is one wire. Lever with I2C. So, okay, so this is not one wire. So I would still need to use an external library. And the subscribe button is right dead smack in the middle of some of the stuff I'm trying to read. Sorry about that. But go ahead and subscribe. Let's see. One dish, one wire. Okay, so it does have, let's see, how does it say to run the one wire? Controls, latest version of the library on the site, one wire protocol, guide, dedicated bus controller, blah, 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 UART controller, bit banging approach. Okay, yeah, that's power one. Yeah, I think this is a powered. Yeah, parasite power mode. Okay. When operating on parasite power mode, only 2 wires are required, one data wire and one ground. In this mode, the power line must be connected to ground. Power line per the datasheet at the controller. That seems like a short, but okay. A pull-up resistor must be connected to the one-wire bus. When the line is high, in a high state, the device pulls the current into an internal capacitor. Okay. When I wire up it, I always use a 4.7K resistor. Normal external power supply. Okay, yeah, so this is, I think, the way I use it. Addressing one wire, single device commands, multiple device commands, single being a one wire device. So this is the one I use, the DS18B20. What is this one? Let's go down another rabbit hole. Datasheet, Oltec. let's DS2438. DS2438. Download. 53669. Download. A unique one-wire interface requires only one port pin for communication. Okay. Smart. Okay, so this is a smart battery monitor. So connects the battery current to be monitored. See text. Connects the battery current to be monitored. Okay, so positive, negative. Okay. Input for general purpose analog to digital. Okay. Power supply. 6 and 7, I guess just because of the form factor. Data output for Q. Okay. This block diagram, figure 1, shows the 7 major components of that. So it's 64-bit lasered ROM, temperature sensors, deep. Parasite power, block diagram, operating temperature, temperature register. So does this have a built-in temperature? Operational voltage register. Okay. Current. Okay. Offset. Laser on the next one. Okay, so you get the serial number. Okay, that's CRC, one wire code. Flowchart. Memory map. Hardware configuration. ROM functions. This may be an interesting sensor to get. Do I have one? I think I might somewhere. I do. It wouldn't be up here. Yeah, give me a minute. Let me go see if I can find it. Okay, so it wasn't what I thought it was that I had. So I thought I had these, but these are, at least how, these are shift registers, and these are bus transceivers. And these I had originally gotten for another project, which I really need to go back to. Kind of another one of my abandoned projects, which was this, which I really need to fix the wiring on. This is a 65C 816, and what I was trying to do is to get the 16-bit register, or the 16-bit mode, which would allow for 24-bit addressing, and that just wasn't working. So that's just, that was that. So where was I? Nope, not the Arduino. Yeah, that's where I was. Okay, so just out of curiosity, let's see if anything. That's an ad. That's an ad. That's a data sheet. DigiKey. Let's see how much DigiKey sells these for. That's the data sheet. That's the same thing I was just looking for. Obsolete. Product no longer manufactured. Outstanding. Let's see. Any other versions? Let's just do a search and see if it comes up with. Yeah, battery management. That looks like it's only gonna come up with. Okay, we want active. Apply all. And I think these are all going to be surface mount. No. Yeah. $8, $9, $9. Okay. Actually, how much do they sell the temperature probes that I am using? Okay, do a search. Why is this off center? Because when I reset everything, okay, that should be better. So, not available. Okay. Coupler's thermal probes have 4. Gonna go with active. 3 actives. Okay, so one's obsolete. That's probably the one that they just showed. So these are all the style I have, and 11 bucks? No way. Granted, that was 5 years ago. About 5 years ago, yes. Beginning-ish of the pandemic. Actually, we could probably figure that out. Let's go back to my channel. 843 subscribers. Okay, I'm getting something different on one of my other screens. So I'm not sure if I lost a subscriber or gained a subscriber, but okay. So we go to videos. Let's go to the oldest. So this is when I was playing with some video capture stuff. Some more, and this was the first actual video I did with camera, and I think I may have re-edited that one. Okay, so yeah, 3 years ago. So 3 years ago was about when let's see, let's go check the exact date of this video. Yeah, I love how I'm getting videos I'm not actually monetized for. Still would need another 157 more subscribers. So this was April of 2022. I probably got, so yeah, maybe 3-4 years ago is when I bought them. I'd have to go through figuring out where I got it. If I got it from like eBay, Micro Center. Let's check that. Micro Center. And do a search. If anyone has any questions, oh, interesting. They don't have it. Amazon, well, that's an ad. New Digiparts. Inland. Okay, Inland does have a version. I don't think I have the Inland version, but these are about $5 each. That just seems high. But again, it's been a couple years, so this is equivalent to the ones I have, and these do they come with the resistors? That would be interesting. So three for $8, little more than $250, like $275 each. Not horrible. These jumper wires, I do have these, and that is actually going to be my first method of troubleshooting. So let's actually get to that. Let's go ahead and start that troubleshooting. So for the camera's sake, I wish there was a way I could just cover that up, but there isn't. So I do have these wires, and I am going to break out. I really would like to use the red, brown, and black, but brown, yeah, I'm gonna go with on this side and pull these three out. I am going to disconnect it from, I'm afraid I'm just gonna knock things out. I need to probably mount these things better. Okay, so I'm gonna pull out these two that I was using as a voltage divider, and yeah, I don't remember which one I had which and what the voltage was, so, or the resistance of each of these was. So just plug these in. So I'm gonna have brown as the ground, red as the ground, red as hot, so those will go right there. And then the D0 pin, which I'm going to go ahead and double check, make sure. I think it's that green pin, but let me just double check. Okay. Make sure I plug this into the right hole there. Okay, so let's see. And now fit in there to, okay. So if I recall the data sheet for this, so brown and hot are going to be these two. I don't think it really matters as long as, and then the D0 would go here, and the D0 already popped out of the damn board. Okay. Now go ahead and plug this back in. And I don't know where my little screwdriver is. Just gonna use my nail. This is actually a little disturbing that I'm not getting any change in this, and it's okay. So when all else fails, you actually should test things. So I'm going to pull out this wire. Do I have a free port on here? Yes. Leave right there. And that's when you need a multimeter. I'm going to set this up to, so it's going to be on, put this on screen. So yellow is going to be this pin here. And black is going to be ground. What do I have plugged into ground right now? Absolutely nothing that I can use. So plug that into ground. So that's, I'm getting 2 volts. Okay. Okay, it is going down. It's going down very incrementally. And you can, I don't know how low I want to actually get this. I'm going to bring this down to 1 volt for right now. And in theory, I can also do that for the backlight. Because, let me move my hand. So that's still a little too bright for the screen. This blue, I wonder if there's a way to turn that off. I think I've said that like 5 times in this video. Get this down to a 1/2 volt for the contrast. Let's see if that is, yeah, I'm actually, okay. I almost want no volt, or at no voltage I actually have contrast. So let's go ahead and see what happens when I reset. So having zero, let me go, is it really zero? Let me bring this down to, so 0.004. Whoops, wrong way. So less than a 20th of a volt. Let's get it to 0.1. This actually, I can actually work with this. 0.1, and the contrast is still pretty good. Do I want to hook up another potentiometer there? So okay, I'm going to leave those probes floating. I'm going to turn off the meter. Get that out of the way. Move this more centered. Yeah, that blue light is really, I just put something over it. Yeah, solar panel. What do I have that I can cover that's non-conductive? Poppy petal? That diffuses it. Yeah, it's still a little bright. Maybe if I fold the poppy petal in half. Nah. Grab a random piece of paper. I should print things with like my logo and just have that there. What are your thoughts on merch? Let's make a poll. Let's see. Start a poll. Should I design and sell merch? Question mark. Yes, no, yeah, sure, that's gonna be it. Start poll. Okay, we have one person that said yes of the two people that are watching. So, a 50% yes. I think I got this from Keats & Co. This bookmark. Okay, so while we do this, let's resize this. And I just resized the wrong thing. This is what I want to resize. Yep. So that's what I wanted to resize. Throw that in the corner. Should I throw in this? Throw it in this corner because that's how it's on this. Yeah. Just throw it in this corner. No idea what I resized. So I got the Arduino up and running. I do have multiple things that I can't think of right now. And which data sheet am I looking for? Is this the right one? I don't think so. I think this was the original data sheet. Yeah, I'm not. Don't mind me not showing it on screen. I'm trying to find the right. Okay, this isn't the Arduino. Okay, this is the Arduino board, so this is Arduino libraries. We'll see. Control V, enter. 07744. And will this open in the correct? Yes. Okay, so what am I moving? Moving the Arduino IDE window. I want to move this one just over a little bit so I can clear that. Move the subscribe all the way down there. I could crop this, but every time I do, issues happen. So maybe I will actually throw this up here. Yeah, that works better. And then zoom in on the data sheet. And I really need to get better at resizing things. Okay. I might be able to zoom in one more time factor. Yeah. Okay. So I believe this is an equivalent board. So here is part of the issue, the VDD to V0. At some point I had that direct, so I don't know if I burnt it out because I didn't have it on a potentiometer as a voltage divider. I'm like, oh yeah, I'll just set the contrast. Typical 3.8 for 75, 20. Yeah. Board typically takes 2.1 milliamps or draws 2.1 milliamps. Yeah, I can go ahead and view angle. Yeah, contrast ratio typical 3. Okay. So ground VDD. Okay, my brain is going to wait, no. VDD, yeah, VDD, yeah, difference between VDD and VCC. Yeah, sure, I'll add VSS to that. Terms used, blah, blah, blah. Okay. positive supply voltage, collector voltage, drain. Okay, so it's just a matter of essentially where that first. Okay, so the difference between VCC and VDD is that first transistor that inside the circuit. I'm assuming the first is used for positive supply voltage, VEE. Oh, it's interesting. I have seen stuff that says VCC and then it says VSS. So VDD. So VDD and VSS should go together, and VCC and VEE should go together, at least according to this diagram. Okay. Just give me a minute. I'll be right back. Okay, thanks for that. Oops. Okay, so back to here. So VSS and VDD variable. So it's low for instructions. The register select is low for instructions, high for data. Okay. It's high to read, low to write. So, okay, we're only writing. Chip enable, high to low is when it grabs a signal. I'll go to the timing diagram in a moment, but let's take a look at if that's how I did the code. So pulse E, I'm bringing it low. I'm setting the data. I'm writing the pins. I'm going high, delaying, going low, going high. Why am I going high again? That could be part of the issue. Let's go ahead and save and upload this. I'm assuming it's going to find the device. Compiling the sketch, uploading. Yeah, I'm pretty sure I want to keep it low at all times. Screen clear. Okay, let's go back to the data sheet. Okay, bit 0. Bit 0. I am assuming that the bit 0 is, so A and K are the contrast, which probably should work on, not the contrast, the backlight. Okay, this is the diagram. The signal driver, okay. Character location, DRAM. Okay. Yeah, that's fine. And built in. Okay, what is this? Function descriptor. The LCD display module is built in a LSI controller. The controller has two 8-bit registers, an instruction register, and a data register. So that's the data select. IR stores instruction code such as display clear, cursor shift, yeah. And address for display data, RAM, DRAM, and character generator, CG RAM. The IR can only be written to from the MCU. Okay. The DR temporary store, okay. So register select 0 and 1 would read busy flag and address counter, okay. Write data to the DRAM, okay. I could do something where it reads the busy flag, but I'm not going to. Address counter, don't really usually need that. The DRAM is used to store display of 8-bit characters. It's extended 80 by 8. Yeah. Okay, these are the characters. So A should be there's a, let's go with capital A. I just saw a minute ago. Should be 0, 1, 0, 0. 0, 1, 0, 0. 0, 0, 0, 1. 0, 1, 0, 0, 0, 0, 0, 1, which I believe is what I started writing. So 0, 1, 0, 0, 1, 0, 0, 0, 0. That seems like too many bits. Zero, 1, 0, 0. 0, 1, 0, 0. 0, 0, 0, 1. So 0, 1, 0, 0. 1, 0, 0, 0 is the letter F. Okay. The lowercase a should be 0, 1, 1, 0, 0, 0, 0, 1. Okay. Okay, so beyond that, instruction table. Okay. So, got the flip-flop between I really should set up something. So these are, let's see, these are where I have everything set up. So let's see if I can read what I am. So set up all the setting all the output pins. Yeah. So the first instruction is 0, 0, 1, 1 and 0, 0, 0, 0. So 0, 0, 1, 1. And just take my word for it because I'm going to be flipping between screens. So 0, 0, 1, 1. So assuming I have this, the data, the bit order correct. So 0, so I'm not worried about those. Well, we are, but they should both be 0. So 0, 0, 1, 1. So 0, 0, 1. So this, so function set DL So I want 8-bit. So let's see. Does it tell me what DL? No. What did? So function set. F is can I tell how many? I'm going to take a look at the screen. Yeah, let me see if I can tell from, see how many dots I can count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. So this is a 5 by 8, which is what I believe I'm setting this to. So 5 by 8. So F should be 0, which is correct. So it should be, and N should be 2 line. I have a shattered 1 line. I think that's why I'm only, so it should be 0, 0, 1, 1, 1, 0. Okay, so let's mess around with this. So if I just select low, 0, 0, what did I say? Function set 0, 0, 1, 1, 1, 0. 0, 0, 1, 1, 1, 0, 0, 0, 0. So the last 2 bits don't really matter. 1, 1. Okay, and this is where I do set it to there. Yeah, let's just see what happens when I upload. And then I am going to cover up the... Okay. Did I hit? Yes, I hit upload when I wasn't paying attention. So it's only doing one. Okay, so let me see if I change this one to A0, the last one I do. And, ooh, what did I do? Upload. And see what happens. I may be misinterpreting the 1s and 0s. No, this is still only giving me one line. Okay, I'm assuming that's a 1. Okay, so now the next line is 1, 2, 3, 4. 4 zeros, 1, 1, 1, 0. Okay, so let's go back to the data sheet. And was it 0, 0? So 4 zeros, 3 ones, and a 0. So that is cursor or display shift. Okay, so we want, that's the one there. SC so do we want display shift or cursor shift? I believe I want a cursor shift. So I'm thinking that should be 0. So 1, 0, 1, 0, 1, 0, 0. So 1, 0, 1, 0, 0. One, 0, 1, 0, 0. So cursor shift. What else is it? Right to left. Right to left. Save it, upload it. Okay, maybe getting somewhere. And then this looks like more than 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I added a 0 here, so that might be throwing things off. So 110. Back to the data sheet. Don't mind me. This project has been throwing me off. So 110. So 1. So it should be entry mode set. So 1 increment. And shift. I don't want to shift the whole display. Cursor moving and display shift control bit. So maybe this one, I was thinking that. So 1, 1, 0. Okay, I think that should be fine. But I got rid of that extra 0. So let's see what happens if I upload now. That would be funny if that, software-wise, that was the only issue. Okay, so let me go back to the contrast and see. Okay, I am going to go back to the multimeter and play around with this for a minute. Okay. Set the multimeter there. Is that even on screen? No. Kind of running out of room right now, so just bear with me on. Yeah, so I'm gonna hook that to there. Ooh, don't touch things. That would be bad. I think I've shorted enough things out, possibly. So right now I have this at 0 volts. I'm not even getting 0.1. What did I do with my tiny screwdriver set? This would make this so much easier. Okay, this down to so okay, let me get this to a volt. I'm not even at close to a volt. Okay, that's a 1/4 volt. Let's see, maybe 1/2 volt. Yeah, 1/2 volt. Those maybe, I don't know. So 0.39, so I'm going to leave it at that and pull these off before I short something out. Turn off the meter, save battery. And back to the data sheet. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay, then I'm trying to write stuff to 1. Let me see, did I have too many bits here? 1, 2, 3, 4, 5, 6, 7, 8. No, I did it again. Too many bits. So 1, 0, 0, 0. And I didn't switch it back. So 1, 0, 0, 0. So display on, cursor on, set display. So display on, cursor blinking. What do I have it as? 1, 0. So I have it going off. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's an 8-bit. So I have the cursor going off. I have display going off, and then I have clearing display. Okay. And it's just so you can see. This is the cursor going off. This is clearing the display. And then, let's see, what do I have next? 1, 1, 1. So let's see. So the display is still off. I just cleared the display, and then I'm setting 1, 1, 1. So what is 1, 1, 1? 1, 1, 1 would be entry mode set, increment. Didn't I just do that? No, I did 1, 1, 0, and now I'm doing 1, 1, 1. And let's make sure I didn't add any extra bits. 1, 2, 3, 4, 5, 6, 7. Okay, 8 bits. Okay. And I'm never turning the display back on. That could be the issue. So let's go ahead and save and upload this. Okay, so let me go back over here. So I think this is okay, 5 by, I think I said 8, right? Let me go, yeah, so 5 by 8. Let's 1, 2, 3, 4, 5, 6, 7, 8. So 1, 1, 1, 0, 0, 0. Double check that. Make sure I have all my comments correctly. So 0, 0, 0, 1, 1, 1. So this should be function set. Okay. So 1, 1, 1. So it should be 1, 2, 3, 4 ones, 2 zeros. Okay. I'm going to leave all the ones before that because I think that is part of the initialization. Let's go ahead and upload. It's probably just one of these things where I have a bit off. I'm still not turning the display back on, which could be a concern. But this is setting up let me get this in the right order. Set up. So this 0, 0, 1, 0, 0, 0, 0, 1. So function set 8-bit. So function set 8-bit 2 row. Let me see this. Function set 8-bit 2 line 5 by 8. 2 row. I'm just gonna put those 2 line 5 by 8. Okay. So now this is 0, 0, so 1, 0, 0. So this is entry mode set. Ooh, hit that one. So 1, 0, 1, 0. Let's see. 1, 0, 1, 0 is display on off. Display on off. Okay. Zero is set display. So set display. Wait, no. 1, 0 would not set display. Which I'm wondering if I have to set display. I'm doing that down here. So cursor. So 1, 0, 1, 0. So cursor set. So cursor. Hey, this is not what it's. So cursor set. Uh, 101 blink off. Blink off. Okay. Now this one is 110, and 110 is entry mode set. Entry mode set. Okay. So entry mode set, and I have 110, so increment. And what is the next one is don't shift display. Shift display. Okay. Still have not turned on display at any point. Okay. One, and if anyone is interested, I am looking at this data sheet buttons with OBS and going back and forth. It's just easier if I just stay on the Arduino IDE screen while I do this. If anyone is interested in what I'm doing, yeah. Yeah. So this one is 1, 0, 0, 0. So 1, 0, 0, 0 again is display on off. Ooh. I forgot to make that a comment. Display. Display on off. Okay. display off. I'm going to say cursor on. Display off. Cursor off. Blink off. So 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0. Am I losing my mind? So 1. So display mode on. Display set is off. Cursor set is off. Blink on off is off. That's how I'm reading that command. That's how I'm reading that command. So this is still, every display is still off. So this is just the last bit, which is clear display. So clearing the display. And now 110. So no, sorry, 111 is entry mode set. Entry mode set. Okay. So this one is increment and shift drift. Shift display. Sure. Display on. Okay. This is where I turn the display on. And let's see if I actually do that. So let's go to the display on function. So 110. So display on off. Display on. Cursor off. Is that correct? 1100. So 11 to cursor off, blink off. So cursor off, and of course, if there's no cursor, shouldn't be blinking. Blink off. One, two, three, 4, 5, 6, 7, 8. Let me just double check that. 1, 2, 3, 4, 5, 6, 7. Okay, so that's correct. Just go ahead and upload this one more time. I don't think I actually changed anything. I think I just added some pins and stuff like that. And does not look like I have a change. Okay. So display sets RS low and then pulses E. Okay. Too easy there. I'm not gonna bother. I commented down there. I'm not gonna. So now RS high. So let's make sure this is 0 1 0 0 1 0 0 0 is 0x. I am having a brain fart right now. I am actually going to use my programmer's calculator just because my brain isn't working, and this is a 8-bit number in binary, so it's 0 1 0 0 1 0 0 0. I'm not sure if that's going to display correctly, but 0 1 0 0. And did I lock up the screen again? I think I might have. Oh, the screen is. So yeah, that's my programmer's calculator. So in hex it is 48. Hex 48, which is decimal 72, and sending an ASCII character because it's set. I clicked on the thing I wasn't supposed to. And just go ahead and 0x482 ASCII. Okay, just okay. So it's the letter H, and I think I did this from Ben Eater's, which if you're looking in the chat, it's that link I just sent. I think that was he did Hello World, and I think I actually looked at a couple other YouTubers that did it, and they did. One of them did 7.2 and 7.3 because it was just easy, and that was doing it without a microcontroller and doing it with dip switches. So there's that. So back to the Arduino IDE, ASCII, capital letter H. Okay. Clear screen. Cursor return. Huh. Let me just double check, make sure I have that clear screen function set. I think so low, 1, 2, 3, 4, 5, 6, 7, 8. Yep, that's correct. Okay, want to leave that H there, so I'm not going to clear the screen. Just yet. Cursor return. Let's see if I have that one set correctly. Cursor return should be 1, 0. And let's take a look at that. Oops, that's the wrong page. 1, 0. Return home sets DRAM address to 00H from AC and returns cursor to its original position if shifted. The content of it is not changed. And 2 milliseconds. Okay. So that looks correct. But I don't know if I want to run that just yet. I think it's been over 2 hours that since I started the What am I doing? What am I doing? What am I doing? And if there's a poll on if I should do merch or not, go ahead and vote on that. And I think I just screwed something up. Let's go back to what I was doing before. Okay, so display char A. So let's go over to the display. Okay. Let's go over to the display char function. And if anyone is interested, it's been 2 hours and I made 107 socks. Let's do a 5-minute timer and I am going to take a quick break. Probably not even 5 minutes, but just give me a moment. Yeah, it's only gone for like 2 minutes. Pardon the crunching in your ear. I was working on a project for potentially another video, and actually this one involves food, so I'm actually checking on something. So I just went to go test on it and take a taste. It actually involves barley. Don't know if it's gonna be something worthwhile for a video or not, but that's where I keep jumping away to. And back to the code. And back to the code, and what was I? So display char. So I think last time we did it manually here. So let's go down to it. Set up data, right pin, high, low, clear screen, return, display on, display char. So we set the RS high, we pulse it with the data, and we return, and we give it 2 microsecond. Should we stream for another 2 hours? I don't know. Let's see. But let's go ahead and we'll set it to focus. Even if I don't continue to stream, I don't think I will be using that. Even though I am using my phone. So it's kind of defeating the purpose. And why am I not running Focus Friend on my phone? Because it won't work correctly on my phone. What was I looking up? My brain's not working. Okay, yes, so print char should be printing A. I'm going to open the serial monitor. You will not be able to see the serial. So A should be 97. So that's what A should be 97. And I can't find my calculator again. Oh, that's the wrong button. Oh. So in decimal, clear, 97 should be 011 000 0110 0001. And that is what should be being sent to there on the display monitor. So That should be working. Okay. Wonder if this, if I turn off serial, wonder if that will change anything. Okay. So setup is a void. Zero one one zero 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 one. Is that correct? 01100001. Yes, that's what I was saying. I have way too many windows open right now. And then delay for almost a second. Should I make it a whole second? I'm gonna make it a whole second. Then loop is also a void. So it doesn't need a return. I'm not sure where, if they did return anything, where it would return to. So still not doing clear screen or cursor return, but I'm still having delay there. Pin display car 8 A, and I'm going to delay a half a second now, and then I loop. I print how many times to the display, how many times I'm looping, which at this point, let's see. Okay, I'm on 76 of the loop. Let me go ahead and reset. Actually, I am not going to reset it because I may have made changes. So I am going to save it and upload. And display kind of turns on. Kind of. So let's go ahead and go back to the data sheet. Okay, so if we do read select 1, read write 1, read select 1, read write 0, sorry, should write data to the DD-RAM. Okay. So let's see if I have the timing right. So read select needs to be low or high depending on how it needs to be set. So read select needs to be set. Read write needs to be set to 0. And enable needs to be 0. Okay. Let's go back to check this pulse function and see if we are following that. So read write is 0. Enable is low. Set up data. Write pins to data. Yeah, let's put a delay here. Delay, let's do 2 microseconds. Semicolon. It's actually, let's check that timing. See if that's what it wants. It's 2 microseconds. So between the read write pin, so between writing the data and transitioning low is TSU2, which is 80 nanoseconds. So that's plenty of time. There's no max. The rise and fall is max. So I'm assuming, and without an oscilloscope, I don't think I have the tools to measure that. I'm assuming the Arduino is triggering that fast enough. So what am I saying there? Move this out of the way. Actually, I'm going to do this backwards. Onto the screen, and let's see if I can show this correctly. So let's just say that this is E, and this is, I'm going to say this is 0, and this is, which is low, and this is high, and we'll just, high is 1. We won't worry about what the voltage is, and that I am actually going to check to see. Yeah, my multimeter does not do timing. I would need to set up an oscilloscope, and I don't know if I have. I think all my oscilloscopes are not set up. I haven't set them up in years, but they are all analog scopes, so I don't think that I have a way to capture. So I wouldn't be able to capture a time period, which would be needed. So to go from low to high, it goes low, it goes high, it goes low again. But what this timing sheet is saying is that it needs to be within 20 nanoseconds. So my concern is, and I'm assuming the Arduino will do it correctly, is that instead of doing this perfect square wave, is that when it's rising like that. And then, am I still on? Let me just move my screen, move this over a little bit. And then when it's falling, is that the phrase it uses? Rise and fall, yeah. When it's falling at a certain period of time. So whatever this interval, and yeah, it did actually did like this interval needs to be I always get the less than and greater than symbols mixed up. Needs to be, yeah, it needs to be less than 80 nanoseconds. So that is when it's doing the, what is it? The right on screen. No, I'm not. Keep moving stuff over. Okay. So when it does the right to pins? Or nope, that's not, that's the function I made. Digital. Yeah, so the digital write function for the E pin, when it's doing that, that is not something I have control over. Well, not unless I really change any circuitry. Like if I added a charging circuit, a capacitor to it or something like that, where it would cause this to charge and discharge. But from the data pin, I am assuming that this is already in place. So we'll go back to that in a little bit. Let me see. Can I throw this back on? There. Is that the right spot where I want to put it? Close enough. And resize this. Oops, I am off screen. Why am I off screen? I don't know. Okay, so back to the data sheet. So I'm assuming all these minimum times are definitely in place. Not reading, so I'm not going to concern myself with the timing diagram. So initialization. So we need to wait 15 microseconds once after VCC rises to 4.5 volts. We are assuming it's already at 4.5 volts, but let's go back to the Arduino and let's see if I'm setting this up. So back to setup. So we're not digitally writing anything, we're just defining stuff. Now we are in setup. Okay, so yeah, this is where I'm waiting a full second, so that should give me plenty of time there. So I'm giving it a second before I set anything. So I'm setting all these to output. I think it was a Ben Eater video where he did cover this to, before you set the pins to output, you should set the mode. And he did this with the 6502. I don't know if you can set them, if you can digitally write to a pin before setting it as output. So, okay, so it's waiting a second. So starting setup. Setting the outputs. And then doing this first. So let's go back to the datasheet. And BF cannot be checked before this instruction. So we aren't checking BF. So but let's go ahead. So we want 0, 0, 1, 1, and I guess the rest are zeros. And this is initializing. It doesn't say initial. So 0, 0, 1, 1. And just so I don't have to scroll back and forth, I am just going to open this up in a seconds tab and go to the instructions. Just so I can reference back and forth without having to deal with the rest of that. And this one I'm at 150. I probably should do the same just so. So it's saying to use 0011. So 00, so bit 5 should be 1, 1, 1. So function set, 8-bit, and the rest zeros. So let's go back to the Arduino. And that's probably that. So 1, 1. What is it? And don't mind me, I'm switching back and forth. 00110000. And we are not doing that. 011. Okay. So 0011 and then 4 zeros. Sure, we'll set that. And then it's saying to do that, wait more than 4.1 microseconds and do it again. Okay, so back to the Arduino. And this is where things are going to go. So I'm going to just put in from data sheet setup / init. I'm going to give it 5 microseconds, even though I'm going to do another delay there. Do it a second time. And back to the data sheet. So it wants to do that, what, twice? So it does it once. Does it twice. Does it a third time. So that's going to set this to 5 again, just to be on the safe side. So I'm just going to say 2x for right now. $3x. Okay. Oh, yeah, I'm still on the data sheet anyway. So I did that 3 times. That's correct, right? 1, 1, 2, 3. So now 1, 1. Function set, 8-bit long, specified number of display lines. So this should be the 1, 1. So 1, 1. So 1, 1, 1, 0. So 1, 1, 1, 0, 0, 0 should be what I should have set. Let's go back to the Arduino. And we are at 1, 2, 3, 4, 5, 6, 7, 8. So it should be 0, 0. What did I say? 0, 0, 1, 1, 1, 0, 0, 0. Okay. Okay. Does it say how long I have to wait between each of these? Even though I think I'm definitely giving it enough space. So I set function set interface, okay. Display off, okay, I think we did that. So 0 0, so 0 0 0 0 1 0 0 0. And check that. What does it want? It wants 0 0 0 0 1 0 0 0 1 0 0 0. Display or off. Cursor off. Still part of the initiation. Let me mark that down. Init from datasheet. And also put that here. So at least I know where I'm getting this information from. Okay, and so that's that one, and let's see what the next one is. So this one is, so this was display off, display clear, so all zeros and a 1. I'm missing something. 1, 2, 2, 2, so all zeros and a 1. Did I? Okay. So digital right, select, low, delay, 4, pulse, E, 0, B, 1, 2, 3, 4, 5, 6, 7, 1, comma, pin array. One, 2, 3, 4, 5, 6, 7, 8. Yep. And that was display clear. Display clear. Part of init from datasheet. Okay. So that was there, and then entry mode set. So we want to increment, and what is S? Entry mode set is move the cursor and shift. So we want 1 1 0. Okay. So 1 1 0, and this is also part of the initiation. double check. 1, 2, 3, 4, 5, 6, 7, 8. So 8 bits. Back to the data sheet. Initialization ends. Okay. So this is 8-bit interface. Power on. Okay, so this is the 4-bit interface. Okay, quality assurance. At no point does it turn the display back on. So. Okay, so I think it's repeating it here. I think this is okay. Let me clear these. I'm gonna delete all these. I think these were all. And let's save. And upload. Digital write not declared in scope. Oh yeah, because it needs to be a capital W. Yep, I know. Capital W. Save. Upload. Display went off. Okay, it's starting the loop. Okay, selected port does not exist on board or connector. What? Uploading. Selected. Okay, I'm gonna save this. Let's see what happens if I close it. Go close it. And I am going to unplug there. I am going to reload the Arduino IDE. Let's see if that grabs it. Okay, it reloaded the sketch. And I don't see it on the screen. It still has the old one. Turn it off, turn it on. Nope. And selector, window, sketch, share. Okay. So that's set up. I'm going to plug that back in. It's going to run the old program. And I'm going to let's compile it first. Let's see what happens when I compile it. Okay, compiling done. Uploading. Writing. Uploading. Done uploading. Okay. So it didn't fail that time. It still didn't do what I wanted it to do. At least as far as I can tell, it hasn't done what I wanted it to do. Open serial monitor. Is it resetting? I think it might be resetting. Maybe? Nope, it hit the loop. Okay, so it did hit the loop. Okay. Yeah. You can't see the serial monitor. Let me think this through. Let me go double check on my other project. If you give me a moment, I'll be right back. Okay, so I'm a little stumped here. So now the other thing I can do is start doing some analysis. So ways I can do the analysis. One of the things I can do is I have a logic analyzer that will do 8 channels. We'll do 8 channels. One, two, three, four, five. Yeah, it'll do 8 channels and it has 2 grounds. I really wish it would do 8 channels and a clock. But we do what we can do. This actually uses the mini connector, which wouldn't work if I had to run it there. Except when I ordered the solder, I also ordered some new mini connectors. So I do have 2 of these. I have not set up the software on this computer, and I am not about to set that up just yet. I'll do that offline. That's going to be checking a bunch of things that I need to check. So in the meantime, so I already checked the voltage on there. So now let's check the enable. So it looks like the enable pin is triggering. But let's see what voltage it's triggering at. So the enable pin is connected to this blue wire there. Which do I have a free? I'm confused right now. I just lost a wire. Did I lose a wire or nope, I put it down here. Okay. So that's my ground reference. This blue wire I should be able to get right in here. And okay, so you can see there. Okay, so set this to 20 volts. As I place the stack stuff. Okay, don't need the. Okay, this is underneath the paper. So let's see if I place that there. Make sure that this isn't shorting out to anything. Oh, I completely disconnected the hot lead. Okay, that's insulated, so that should be fine. Grab not the hot lead, but the positive probe. And set it there. And this is interesting. Okay. Okay, so I am going to in the pulse E function, I'm going to give it one hell of a delay just so we have time to read it. Display I think pulse A was one of the earlier data set. Clear screen. Digital write pulse E. Okay. Where do I have pulse E defined? I thought that was... Okay, set up data. Write pins. Pulse E! Yay! I am going to give this a... That should be a full second delay there. When it takes it low. We'll do a couple... No, we'll do 1 second delays here. No. That's not there. So when it goes low, we'll give it, let it go high for at least a second. And high for at least a second. And we will upload. And well, that's uploading. Let's see. That's interesting that E is at... Okay, so it's high, it's low. It's high, it's low. So now let's go back to the data sheet. And that's the backlight. So backlight. And reliability. Stuff about the screen. This is all timing diagram. I just want to go back to more timing diagrams. Where was it that? I'll make sure I'm within the voltage. View angle, okay. So supply logic from the pins, and this is interesting. This, I don't know if it's a delay in my meter, but I am getting every so often, so it's going to 4.6 as the minimum and 5.5 as the maximum. So this is, I may be going too high on this. Okay, so let's go ahead and let's actually see what I am getting for VCC, which I believe I am triggering off of that pin there. And 4.67, and which is exceeding the supply voltage by almost a half a volt. But the only other option I have is the, can't remember which pin that is. Is the V3 pin, which should be, yeah, 3.36. But in theory, I can set the pulse a 5-volt pin. So I believe this is the 5-volt pin right there. No. No. What pin do I have that connected to? A2, A3, A4, A5. Oh, reset is. Okay, so it's actually back here is 5-volt. V in, ground, reset. So it should be the 4th pin over. 1, 2, 3. Okay, 4.6. This 4 points. Oh, that's why. Okay, so V in is 4 volts. Okay, so that should be fine. .9 volts for the LCD. Let's back to the data sheet. That was like the last page. Backlight, voltage, okay, typical is 4.2. There is no minimum. Okay, so I do have some more potentiometers. Where do I want to connect the potentiometer right now? Yeah, let's connect the potentiometer, and we'll do yellow, green, blue for this potentiometer. Probably should unplug it. I'm gonna go with I'm gonna go with blue as the voltage source. So we're gonna pull this one out, and I'll stick this somewhere. So I'm gonna go with blue is the data pin. Green is ground. I could vent, and yellow is hot. Okay. Or positive. But I do not like the term ground when nothing here is touching the ground. Well, maybe through this, the shielding on this cable to somewhere, it's not grounded. It's ground in electronics is a big misnomer. Okay. Grab another potentiometer. Not like this is going to change any of the data, but there's still something with the data not working, and I could try 4-pin, but I think the next thing I'm going to do is possibly take this out and hook it up to what's it called? A Pico. Oh, I should probably eat lunch soon. So that should be the voltage, and I don't think it matters which is positive, which just when I turn the screw, it's going to matter. And we'll go ahead and stick that there to get a voltage. Plug this in. I'm getting 2 volts, which almost nothing on the screen. And going the other way. Okay, let's see. I think it was close to 4 volts before. This is actually interesting. I am not getting anything on this display. Did I screw something up even worse than I did before? Nothing should be shorting. I'm actually... This is really sensitive. I still need to charge the AC in my car because that's still not working. Okay, starting to get a display. Maybe I'll go to 3.3 volts. And this really defeats the purpose of what I was trying to... Okay, how's that look on the camera? That blocked out. Still... That's still not bright enough. Almost 3 volts. So 3 volts. Okay, so backlight's not, so no. Okay, so that should be fine. Oh, did I? Wow, I timed it out. Okay. Okay, I'm stumped. I really am stumped. So what I'm actually going to do is I am going to pull this out. No, I'm just going to do some checking on this board. Okay, let's... I am really stumped. I'm going to take a break from that right now. And work on something else. Oh, what? Something else I wanted to work on. Get the probes out of there. Now let's see if I can put this back in the way it's supposed to be. Okay, everything is lined up. It looks like it is. Maybe? One. Okay. Get this out of the way. So this one, I believe this is a 5 by 11. And this is, let's see. If I power up this, I can check, but this is a lot bulkier. And not really sure what any of this is. This is a 5 by 10 or 5 by 11. And I don't really want to play around with that one just yet. Make solder pins on there just to solder pins on it at some point. There was something else I wanted to solder. And let's set up the solder. My brain is fried. There was something else I wanted to test. Oh. Well, I'm thinking of that. Let me grab this. I think this is a 1/2 volt. I don't think this is a 1 point. Yeah, this one I think is a 1/2 volt. I think it's, if I recall correctly, I think each side was a, no. Okay, so can't remember which side is positive and which side is negative for these pins. So I'll test this out. That should be negative and that should be positive. Just looking at the way this seam is. Okay, there it goes. I am literally getting more light when I face it down than when I face it to, okay, now I'm facing it towards my, and that just could just be loose connection. Okay, so this is a 3 volt ish cell. In theory, I can power, I don't know how much current I'm getting, and I don't feel like putting together a circuit to measure current. So we did troubleshoot that board. It didn't bring us anywhere, so I don't know if it's a hardware issue. I don't think it's a connection issue. I think I have everything connected correctly. There's actually one more thing I wanted to test. It just came to me. Gonna do that and just about my brain is fried. This has been driving me nuts. Now I think I have the initialization set up. The only thing now is where am I going to put this potentiometer so I don't misplace it again? I have a bunch of stuff that I keep misplacing. I still want to do a video on this if I get this working correctly. This is an inductive circuit, and I don't feel like opening the plastic, but I have another one. Yeah, let me go get that other one. Give me a second. You're probably tired of me doing this, but let me go get that other one. Okay, so I got the So I got this. This is the other one I have. I think I burnt this out. And the way this device works is, well, it generates basically it generates a frequency, and it's in the, I believe in the megahertz. And when you have that frequency, anything ferrous that is near or inside this coil will heat up. And I believe input voltage is between 5 and 12, and input current is, what's the input current? Income must MU. Yeah, I don't know what that's saying. If it needs to be at least 20 amps, I was using a 10 amp, a 12 volt 10 amp, which don't think that's, and I need to get better wiring. I don't think that was, this wire is rated for 10 amp. I don't even see any data markings on this wire. I believe this is phone wire. Wow, this is like really, yeah, let me see what gauge wire this is. Give me a second. Paint. Yeah, I don't think it has some coating on it, but I'm not actually seeing. I think it's all worn out. Or this piece is not long enough to get. Slash, yeah, it's a foot marking, then yeah, so this is probably not rated for the 10 amps I put through it. Let's look that up. Okay. That out of the way. Let's just shut off that for right now. And gauge for 20 amp. Let's see, it should understand. So for 20 amp, I should have at least 12 gauge wire. For 10 amp, oh, there's a calculator. So 12 gauge. System voltage, 12 volts DC. Load amps 10. Distance in feet 1. Circuit type DC circuit. I love how it is voltage and then the circuit type. Conductive material. Calculate wire size. Did it calculate? Woo! Right. 1 gauge. 1 gauge wire. Are you on crack? See, 20 amps. You have to be on crack. Let's go with 2 amps. Yeah, this calculator isn't working. So, okay, so 15 amps is the lowest this will go down to. So let's see if I put 20 amps and calculate. Let's see if I can find a different calculator, because that's just wacky. Table, yeah, table should work. Voltage source. Enter voltage at source 12. 10 amps. Okay, single phase, yes. Insulation, yeah. Copper, insulation, cable, voltage drop, sure. Distance, again, 1 foot. Calculate. 14 gauge. If I bring this down to 8, still 14. If I bring this down to 1, yeah, so this calculator, the minimum is 14 gauge. Which I think is dealing with, and I opened that twice, which I think is just dealing with household wiring. Okay. DC single phase, okay. Voltage source, 12. Allowable voltage drop, yeah, we'll go with 3, yeah. Current, 10 amps. Distance, 1 foot. I think just I'm not hitting the minimums for most of these. So 20 gauge wire. Okay, so 20 gauge wire for 10 amps. And it's probably going to give me 12 again if I bring this up to... Oh, current's over here. If I bring that up to 20 amps... Really? Still 4... Okay, so 20 gauge at... So 15 would get me to 16 gauge. If I did the full 20... So 14 gauge wire at 20 amps. Okay. if I was able to go to 30, which I've seen similar devices like this, that would be 10 gauge. I don't think I've ever seen F40, but 8 gauge. 50, this should bring me to 6 gauge. Nope, still 8 gauge. 60. Now it brings. I'm trying to figure out how much current it was expecting to go to get 100 amps, 3 gauge. Well, no, 80 amps. So 100 amps would get me to 3 gauge. 150 amps, which is crazy. 1 gauge. Okay, so 125, 1 gauge. So 125 amps, which is 125 times 12. One 25 times 12 is 1500 watts, which would be the equivalent of a heater if you did you reverse the voltage and the so I think you would at 120 times 15 would also give you 1800, so which is 1800 watts is the most you can usually get from a household. Usually it's 10. So right now I have two 100 watt solar panels. At the 12 volts each, that means that they are drawing 16 amps. So let's go back to that calculator. And there's an add. So 16 amps, 12 volts. Now let's say between the solar panel and the charge controller is 8 feet. I would need 10 gauge wire. Okay. 10 gauge wire is a little hard. But back to this thing. So yeah, you can see right here, I started to melt the connector. It got so hot. Now, I am going to go from voltage to continuity. Oops, wrong way. That should be the continuity tester. Okay, so if I connect there and there, but so this coil is insulated. So now okay, so those so even if this pin is wiped out, actually let me yeah, because what I had used was something I misplaced already. Was a empty CO2 cartridge. This is actually a CO2 cartridge for a drink carbonator I have. So I'd put it in here, and this, if there was any vapor in here, yes, you would heat it up. It would, I don't see it having an issue with exploding, but okay, so now I don't know if I burnt out any of the other circuits. This is kind of hidden. Actually, what? I wonder if these are more coils. This should be the same one as this, but I don't know if that is a QR code. That is a QR code, which I could probably try to run through a QR detector on the computer, but well, okay, so the QR code pretty much is that number. So let me go ahead and pull up that number and see what we can find. See if we can find a data sheet on this. 10131 901 22711. Let's see if I come across anything. No, it did not find anything with that number. Let's see if Google finds anything. In Denmark. Oh no, Germany. Yes, so this is a flyback drive heater. Yeah. Induction heater model, New Zealand. Okay, let's. Sure, I accept this craziness. Okay, so this one says it's 150 watt, and I can't really zoom in where I want to zoom in. So that's 10 to 12 watts there. Minimum wire one. Okay. The ZVS driver module. This is a minimum VVS board without heater coil. Okay, I have the heater coil. Without heater coil transfer, etc. Okay. Working power range, maximum power is 150 watts. 15 volt inductive heating. Slide the transformer 12 volts, the primary 5 plus 5 to the approximately 30 watts. Okay. Working voltage rate is 5 to 15 volts. Note, make sure all components are soldered correctly. Yeah, okay. We want to see the other side to see if that. See what the. So input voltage 5 to 15 volts, maximum power 150 watts. So that no, so this one's according to this one's only 10 amp. Okay. This one also looks like it is 10 amp. It looks like the same one. So what is this called? Search ZVS. Zero voltage switching. Induction module. Let's see, is this one in the US? Okay, let's go ahead and close these ones. Okay. Okay, this just gives the voltage. Similar concept. If there's no welding, need to weld by yourself. Okay, weld? Okay, so let's see if we can find. So that one still, I should probably search for data sheet, but okay, that's an ad, that's an ad, that's an ad. This is not an ad. Yeah, not in the US. Related. Okay, nope. $1,000 watts. This would be okay. This one's a little different. This one looks a little bulkier. Okay, this one's a maximum current 20 amp. Input with no current, with no load, 3 amp. With 48 6 amp. The higher the voltage, the greater the heating current. When the same thing, the effect is better. Okay. Yeah, that kind of makes sense. Or voltage. There's no markings on this with a that I can do. Not on the module itself. So I am wondering if I take this, if the distance from here to here makes a huge difference. So if I, let me pull this off so someone doesn't think I'm building something I shouldn't. If I move this further away, this is the whatever metallic item is in here is what's generating the heat source. Now, with this being there, the heat is traveling. But I don't know if I move this further away, say another like 2 feet, if that would affect the heating element. So again, I only have 10 amp, and it kept shorting because I think it was trying to draw the full 20 amps. So 20 amps at 12 volts is 240 watts. Whereas 10 would be 120 watts, and I'm using a calculator because my brain is fried. Let me see if I can go find the power supply. Give me a minute. Yeah, so I found that it's kind of tangled up, so I am just going to pull up, see if I can pull up the data sheet on it. And it's 8.5 amps, which is less than what I had thought. It's been a while since I've used it, so it's an S112. It's a fairly, yeah, that's it. Meanwhile, we'll go with Amazon and we'll go with the data sheet. Yeah, for some reason I can open that in a new tab. I maxed out on tabs. Okay, so this is the power supply that I was using for the inductor. So output 100 watts. And so I think I paid a lot less than that for it. So I would want a 20 amp. So 15 volt, 20 amp power supply. Let's see if I can. Yeah, I'm not going to spend $1,500. 20, maybe. Let's see. What is this one? Input voltage. Okay. Output voltage. Oh no, that's 20 watts, not 20 amps. And let's see what this one is. So this one is, again, let's see, meanwhile, power supplies. If I can find a model. Meanwhile, okay, so there is the, I have way too many tabs open. So RS, let's see. Raspberry Pi Arduino development tools, that's interesting. Power products. Alternators, generators. You could possibly play with one of those. DC to DC power supplies, DC to AC power supplies, solar chargers, power supplies. Select output voltage. I'm going to go with let's go with 12 volt because that's going to be the most common, and 15 volt. Yeah, we'll go with it. Yeah. So how many are listed here? 2,000. Yeah. Any way to select series. I have no idea what those series numbers are. And let's go back to going only with meanwhile. So 600. So this is a 15 volt 2 amp. Let's sort by price. So this one is a 12 volt 40 amp. That's more than we need, and that's $500. Let's see what we can find for under 200. So 201. This is a 15 volt 64 amp. That seems still a little overkill. 12 volt 33 amp. Product is discontinued. Why are you sorting it by price if it's discontinued? 15 volt 40 amp, again overkill. It's interesting, they're going lower in price. 12 volt, 22 amp. That's close, but still, that may be overkill. I always find that interesting when web pages, you select the next page and it drops it doesn't it resets the table. It doesn't bring you to the top of the table, which is interesting. So this is 15 volt, 10 amp. 15 volt, 19 amp. That is the closest we've come. The fact that this looks like a power supply for a laptop is a little discerning. Okay, this one's discontinued. 5 amp. Nope. 36. 23 amp. Yeah. 37 amp. Woo! That did not mean to do that. 15 volt, 13.4 amps. 15 volt, 11 amp. 12 volt, 50 amp. Oh, discontinued. 12 volt, 64. Nope. Yeah, we've been at this for almost 5 hours because I think the second branch of Focus Friend just reset. 12 volt 53, 12 volt 43, 15 volt 30, 1237, 1511, 1519. That's actually product is out of stock. Okay, well, I can always look. 1222. Page 3. Now I'll scroll up. 15.6, no, 15, 12, that's close to what I already have. 12, 15.10, that's navigation. 15.25, a little overkill. 12.21. 15.17, that's actually pretty close. Probably find it cheaper. 15.11, not really. 12.80, yeah, that's a lot. 12.13, 15. The fact that it has 2 voltages here makes me, 2 amperages here, makes me wonder. power supply medical. Okay. 300 watts. That's roughly what I want. Again, it's a little overkill. I don't know if that's going to short it out though. Okay, did another 2 hours on with Focus Friends. No, let's not take a break. Let's just focus again for another 2 hours. I am not going to stream for another 2 hours. No. I need to eat something. I could eat. I think I have lollipops still in my house. 12:41, 12:41, 15:26. This is a Euro plug. Don't need that. 12:41. Yeah, so even if I scroll it up and down, I still need to go to the bottom to go to the next page. So might as well start from the top. 12:15, 15:07, 15:20. Discontinued, of course. SP. Okay, and it needs a input voltage of, so let's see, SP320-15. SP320-15. Let's see if I can find that one. Of course, it's an ad. DigiKey. Interesting. Digiport. Amazon. Yeah, let's see how much Amazon wants for this part. $101. Okay. Let's see. 300 watts. No data. Usually it has. Yeah, not very efficient. $12.25, $15.19. Well, that's almost what I have. $15.15. Maybe. 15.19. $15,500. So that's everything we want is roughly 300 watts, right? Let's see. 15, 20. Yeah. Want something roughly 300 watts. Oddly enough, I could probably do it with my solar panels, or pretty close to with my solar panels. 1222, 1216, 1526. Maybe. Which I really, it'd be an interesting project, but if I don't find an actual use for it, it's not going to really do anything. Well, if I just do it to do a project on the channel, I'm nowhere close to being monetized. So I don't know, should I sign up for a Ko-Fi? Would anyone give me any money for a Ko-Fi? I doubt it. There's people that give for a lot for anything, and they're fine with that, but don't know. Okay, so did I just, okay, I think I just hit page 5. I am delirious. It's been 5 hours of me streaming. 1519, yeah, that one's out of stock. 15.5. 1520. This is ideally what I would need. So this is the RPS 315C. RPS 315. I don't know what C. We got ads, we got ads, we got ads. Mauser. Okay. Mauser has it. Why? Oh, because I put 200. I want 315C. And Mauser probably got me the wrong. Add. Oh, Mauser does have 315C. DigiKey has it. RS is where I'm searching. And let's. And Amazon. Okay. Not sure what the difference between the 15C and the 15 is. Let's take a look. Oh, C, cover. That's okay. So $5 for a cover. Okay. This power supply has passed the medical safety cert. Okay. Don't really need it to do that. Okay. 5 inches by 3 inches. Okay. Medical approved. Okay. Suitable for BF applications. No load power consumption, 5 watts. 5 volts is standby output. Okay. Protection short overload. So yeah, I think that's what I was happening with the inductor is I think I was hitting, it was trying to pull too much current. So if I had something that was more than, that's what I don't understand. I'm not sure if these devices will current limit, meaning if I hook up a 30 amp power supply, will this thing try to draw 30 amps? Or do I need to keep it at 20 amps to prevent it from frying? So I think I have both. I have red. I think I have red 12 gauge. I don't know if I have black 12 gauge. And the other thing is, I really need a lot more room because this thing gets hot. I don't want to be anywhere near anything flammable. So I generally, when I work on this, I work on a steel workbench, or not steel. Actually, last time I did it was on a steel panel, which something not directly flammable. I will do certain plastics, something that doesn't have a quick ignition point. Even like a hardwood table or something where if I'm there with proper items like a proper fire extinguisher or proper fire blanket, then I'll use it there. But this, and I haven't been able to get a good heat source, primarily because I did try to use the temperature probe, and I think the inductive current was creating enough of a magnetic field that it was interfering with the measurement. Plus, I think it was exceeding the temperature. So the other thing I want to do is, again, because if there's anything in here, this could become a pressure vessel. It's meant to hold pressure. Is probably get a hacksaw, cut it open, and maybe even cut open both sides. Fly. So there's that. So this is one project, and I'm gonna go take this away and put it somewhere where I will not forget it. Of course I'll forget it. I have so many half projects sitting around that it is driving me nuts. So don't need, this is all caught up. Don't need the meter right now. I can have my Don't need the meter right now. Do not need the solar panel. I'm going to be playing around with that. Don't need my bookmark. I might need, because we are going to try this one more time. And it's USB, so you always just try it 4 times before you actually are able to plug it in. There it goes. So, throw that up there. Move it this way a little bit. Actually, if I move it down, okay, close enough. And then I go to the Arduino. And I'm going to, bring this back to bring it to 4. Okay, this is where I should have made note of what I set delays to. So now I am going to reverse the bit order to see if maybe that's where I screwed up. I don't think so. So 0, 1, 2, 3, 4, 5, 6, 7, and upload. And see what types of weird things we get. Uploading, uploading, uploading. And oddly enough, we get exactly what we got before. Which makes me believe that I shorted the hell out of this thing. Okay. Uploading it one more time, just to make sure. One, two, let's see, how much of a delay? And tool system monitor, which you can't see because OBS treats it funny. And it still hasn't, okay, it just went to the loop. And nothing. And I'll have to go back in. I'm in the loop, I'm not clearing the screen, right? That would be bad. That wouldn't be fast enough to even see. So loop delays, delays, puts the character, delays, loops, yeah. I did figure it out on I2C. I could try to figure this out with, but I really would like to figure this out. Probably should not have done it with the Arduino. Just should have used the full-size breadboard, and I should use the full-size breadboard, and I should have used a Raspberry Pi Pico. Yeah. Okay, so this still isn't working. I was really hoping that I would get further on this. And now I find my screwdriver set. And the box that power supply was in, not like there's any data markings on here, but so the other thing, there's a couple other projects I was gonna possibly do during this live stream, one of which was actually going to be doing not the Arduino. Did I not set up the screen capture correctly? Okay, so wasn't gonna do the Arduino. I was going to, well, I was gonna do the Arduino, but and now I can get the data screen to show. No idea why I couldn't do that last time. But now it's... yeah. So now I can get the print screen going, and so you can see that it's up to 70 something loops and still nothing. That's not what I wanted to do. I want to do this. So I was thinking of using KiCad and actually drawing out the diagram of the That wasn't good. I just hit the camera. Okay, didn't move it too much. So I was gonna do a schematic of this, and do I have a or did I close it? Yeah, so I have a schematic which oddly enough is the schematic of that I have in this video that's showing on the samples and tests webpage. So this is when I designed the one with the 8-segment display, and I'm pretty sure that this is accurate, and I don't think I have this PDF saved right now to load it up, but I really should look for it and then see if because, well, I don't know about with current tariffs. Let's see, PCB. Let's see. Well, let me search the channel. Nope. Pico. Okay. Yeah. Okay. I can't remember how I have that Google search set up, but if either from JLB, PCB, or some other, I think even KeyCAD, not KeyCAD, DigiKey. Actually, let's check out DigiKey PCB. I love how, yeah, oh, those are all ads. Turnaround and shipping times. Turned on and required registered today, blah blah blah. No communicating with suppliers. The board has any questions on the order? How to order? RPCB draw advanced circuits. Let's see. It's the largest printed circuit in the U.S. So advanced circuits is in the U.S. So let's see. Okay, so precision equipment manufacturer. Okay. Royal circuits, it doesn't seem to show a seed. Okay. Okay, so that one's in China. That one's in California. Precision is in California. Advanced circuits is in Colorado. Let's just go with advanced circuits. Let's see if we can. I really don't like the way DuckDuckGo does their ads. Maybe I'm just got used to the way the way Google does it. Okay, so let's see. Tools, trace with calculator, get a quote, solutions, advanced PCBs. Okay, so 0 to 10 layers. Yeah, more layers, more. 5-day turnaround. Okay. FR4 is fire resistant something. Lead free how. Okay. That should all be fine. Standard specs. Don't know whether you need a multiple. Okay, so this. Okay, that's a little bit more. Very vented, meteor. Okay. Trying to figure out if they can give a base price. Just type of vias, tinted vias, plugged vias. Scoring, does that okay. That's what I thought. Tabs, get in touch today. Let's just go where to buy. Let's see if it actually order online, leverage online tool, email, regional sales, product sales, get in touch. Get a quote. Let's see. What do you need? Okay, you need an account. Let's see. Ooh, nope, that's not. Advanced PCBs pricing. $33 each. Order 3 or more boards and fits it in 33. Okay. Minimum quality 3. 2-layer board. Maximum of 60 square inches. So 60 square inches. Let's see, what's square root of 60? Is 7.74. So let me grab my ruler and let's take a look at what size board. That's still, it's $100 for simple prototyping. So even like a 7x7 board, is that the maximum? Was that the maximum? Was that the... let's see. Maximum size. No slots or overlapping drill hits. No internal routing cutouts. No scoring. Okay. That's... maximum 35 drill holes per... okay. Nah, that's... you can't have route outs, but if you put 35 holes per inch, per square inch, so yeah, if you put enough holes, you can make your own score marks. Yeah. This is my day. Okay, so I've been at this for 5.5 hours. Didn't get much accomplished. Well, got through a lot of troubleshooting, but beyond that, not much. So I think I am probably gonna go end this. Do want to let you know, I do have a blog, so you can always take a look at that, and I'll just drop the link here in the chat. And in there, I also have my affiliate links somewhere. Affiliate links, yeah, that's the one. I'll throw that into the chat. And really would like a smoker. And this does not look like... I think I'm missing one. I'm missing a couple here, I think. They may actually be... let me see. There's one... I'm gonna up this. Also in the description of this video are more. So yeah, I don't have Pinter and I don't have OneStream listed here. Wonder if I still have those. Yeah. In any case, yeah, from here you can check out my GitHub, which doesn't really have much in there. If you have any inquiries, you can throw that there. I try to check that regularly. But yeah, let me see. No one else is in the chat. Anyone? It looks like only one person viewing right now. So yeah. Let's see. Yeah. Been at this for 5.5 hours. Oh, the other, yeah. was trying to get a circuit diagram similar to LT Splice or LT Spice. Canedia was one I came up with, maybe on another live stream, but make sure on your way out you hit all the things that people should be clicking on, and I think that is it. I'll give it another 10 seconds to see if anyone wants to throw anything into the chat, and I should probably give them more time if anyone wanted to throw anything last minute into the chat, because there is a 15-second delay from when I said that to when it shows up on the actual screen and then somebody types anything. So if you're typing anything, just hit enter or something like that. Yeah. Otherwise, good. Yeah, not seeing anything. Watch, as soon as I hit end stream, it's going to, someone's going to type something. But want to thank everyone who has watched this or is watching this or anything like that.